Okay, so bell work, August 18th, Friday, yay, concerns reviewing or finishing chapter 1, the study guide. So hopefully we're going to finish chapter 1 today. Yesterday we started it, on the backside we didn't complete 1.2. So that's bell work today. I need somebody to record for us. Now is to take some notes on the rest of this chapter. And the first thing we really need to understand is what science is really all about. What is the goal of science? What helps out? What's the goal of science? What's the definition of science? Because we're going into the scientific method, and if you don't really understand the definition of science, the scientific method is going to be meaningless to you.
Just like to understand the originates, understand theory.
Okay. Now, I'm not going to tell you my definition of science. We're going to go to the internet, where we see the Merriam-Webster, because they've been around a lot longer than I have, and their definition is science is a, let me read it here, I can't see it up there. The purpose is to seek general truths or their operation of general laws. Now if you go to my website, I summarized it a little bit better there. At the top, you'll see science, the study dealing with the body of facts or truths systematically arranged, showing the operation of general laws. Really, it's about seeking what the truth is. Our goal is to determine what the truth is. Is everybody clear? So you might want to write that down. Science concerns seeking truth. That's what we do. Experiments, tests. It's all about determining, separating fact from fiction. So if you flip over the back of your sheet there, you'll see spotting bad science. So we're trying to figure out what is true and what's not true. So in the book, they have some key terms for you. And on your Cornell notes, these would be some key terms that they want you to understand. The first one is mass. Now, mass, what is mass? Mass defines what you have. If you look at John Newlands and Mendel, those are the two that really work on the periodic table. They initially set up the elements based on their mass. So the mass defines, the proton mass is different from the neutron mass, which is different from the electron mass. So the mass really defines what you have. Change the mass, you have something different. So mass is very important. We start talking about matter, right? What's interesting is you can take a proton plus an electron, and what do you get? You get a neutron. So you can make new things when you combine masses, which is really neat. So mass is very important, and it reflects the amount of matter that you have. It's probably one of the most important things to understand about chemistry is that you're just messing with mass. All right, so weight, what's that associated with? Gravity. Is that right? And then we look at how the scientific method is set up. So we've got a little PowerPoint for you. I'll try to post this PowerPoint on Google Classroom. So it looks like this. And the scientific method is a way to try to solve a problem to find out what the truth is. All right, so we're talking now about the scientific method. And what's the first step in the scientific method? No. First step, scientific method.
Make observations.
Make an observation. So the first thing you want to do is make an observation. And then what are you going to do?
Experiment on it.
Identify the problem. So most people just ignore problems. You would be surprised the older you get how often you will ignore problems. The youth and the young are the ones that always observe the problems. They're the ones speaking out at rallies. You never see the old people there. There may be a few. Shouldn't say never. But the majority are the young. The young are the ones that observe, identify problems, try to do something about them. So, you have two types of problems. You have pure research and applied research. So the pure research is you're just trying to gain an answer to the problem just for the sake of knowledge. You're just like, I want to know this just because I just want to know what the answer is to that problem. You're not going to do anything with it. That's called pure research. Gaining knowledge for the sake of knowledge. You might want to write that down. It would be a note, Cornell note. Pure research, right here. Gain knowledge for the sake of knowledge. Why would you want to gain knowledge if you didn't have a problem, right? And then applied research is about solving a problem. You know, there's problems in our community. There are problems with your health. There are problems globally, right? Right, Claire?
Are you supposed to be copying this on
You can. Remember, notes are your choice. Everybody's going to take notes differently, but when you use the same format, that's why we're using the Avid format, Cornell note format. But what you write down is your choice. As long as you have something written down, you're going to get full credit for classwork. Is everybody clear? You might know something that somebody else doesn't know, so you're going to not write that down because you're pretty comfortable with it. All right, so we got our problem. What's the next step?
Do an experiment.
Hypothesis. You want to do a little research, get an hypothesis. What's the hypothesis?
An educated question.
Educated guess. Good. All right, right direction. So it's an educated guess. Now, math can sometimes be a guess because of variables. You got temperature change. Like if you're a baker and you cook one day and there's low humidity, and the next day you cook at high humidity, you're going to get different results because of the variables. So by clear, pressure, low pressure, lots of water, high pressure, it's dry. That can affect your baking conditions. I'm not a baker. I just know that I watch enough little, Food Network stuff. You ever seen that show?
Yes.
You ever seen that channel? I'll show this channel. Okay.
I've seen it.
Yeah, so they talk about how pressure can affect your cooking. Which one? This one? Yeah. All right, so what's our next step? We got our hypothesis, now what are we going to do? Experiment. Very good. Now what are we going to do?
Find patterns.
So we got our experiment, and then we're going to observe results, right? So you see what the experiment did, you're observing some results. Not sure what happened there with my PowerPoint. All right, we'll come back to that. So we got our results. Then what are we doing?
We either revise the hypothesis or come to a theory.
We've got a conclusion. So the next step after results is you make a conclusion. What's a conclusion? It's a judgment. Write that down. You need to know that a conclusion is a judgment. So often I'll write stuff on the board because technology fails. Our overhead just went out. It's not displaying the PowerPoint, so I do write notes on the board as well as a backup. So theory comes next. What's a theory? Right, that's explanation. So if you're a doctor, right, and you're doing knee surgery, ACL, sports, and every time you go into the operating room, that is an experiment. And you're like, okay, this didn't work very well last time, let's change it and do it this way. So you do it that way now, and you got better results, You want to go tell your colleagues. Everybody clear? Tell your colleagues. That's a theory. When you start to explain how you are changing and producing better results, that's a theory. Now, would it become a law? It would take many years for you to do that same surgery and not any change be needed. You have to understand, no change needs to be. That's the best that can be done. Your surgery, your new idea will never get any better than that. Then it can become a law. That's like the law in knee surgery. But laws can change. Not to say they won't. Something else can come along. Robotics, I don't know. Who knows? But laws can change. So what is a law?
Relationship broadly supported by experiments and accepted by society.
That's the most important thing. It is accepted by society. Now, there are some theories that are not accepted by society, namely evolution. You got microevolution, you got macroevolution. You should learn about this in biology. So micro, what's that about?
Microbiology is the study of microorganisms.
Okay, what about microevolution?
Microevolution is the evolution of microscopic organisms.
Okay, that's good. You're close. It has to do with these small gene changes. Like, say if I have insulin. Anybody who's diabetic?
Oh,
You ever heard of a diabetic person?
my mom's diabetic.
Okay, so they have insulin problems, right? So they have to inject insulin when their blood sugar levels are too high. The insulin helps the body take the sugar into your muscles. Everybody clear on that? Now, if you have low blood sugar, you can die. What they call it diabetic. People die. I had a friend who died last year from diabetes. Anyway, so if you take the insulin gene out of a human and you put it into a tobacco plant, that would be microevolution. Another example of just breeding, if you breed for white sheep only, why would you want white sheep only? Black sheep is the normal. Why would you want white sheep?
To dye different colors.
Smart. Yes, dye the wool different colors. So you can wear different colored clothing. In the wild, white animals are easy targets. The white alligator at the zoo. You put a white alligator in the wild, everybody's going to see it. The predators are, and they're going to easily kill it. That's why when the Indians saw the white buffalo, they were like, ooh, they didn't have their outfit. Because it's normally easy to get killed and captured by a predator. Alright, so that's microevolution, small gene changes. You can do it with peas, men will do it with peas. You can do it with crops. You can do it with chicken. You can breed. Breeding is basically small gene changes. If you didn't know that. You're breeding for one specific purpose, a small gene change. The dominant recessive. 99% of society accepts microevolution. It's the macroevolution they have a problem with. Macroevolution has to do with what?
Chromosome changes.
Chromosome changes, very good. So you've got two major things happening here. You've got a type change and a number. Write that down, these would be good notes. If it changes in type, and it changes in number. Those are the two requirements for macroevolution. Now, there are a lot of people out there that don't believe that. They say, no, the chromosomes have been the same since, creation, Genesis, been the same. They have not changed them since then. So they don't believe they change in type or number. Now, let's examine parthenogenesis, right? So parthenogenesis is virgin birth. There's a gene for this. It happens in Komodo dragons, it happens in zebra shark, it happens in a lot of species. Drone bees, all male drone bees are conceived by parthenogenesis. Ants do it as well, because all male drone bees are undergoing this cycle, called cycle, because there's a gene for it. There's just too many things happening by it for there not to be a gene. So, there's a gene for it. Now, if we examine parthenogenesis, you've got, let's say you've got a female, right? And the sex chromosome for the female is what?
XX.
XX. It's the 23rd, it's XX. So if you have a female, by parthenogenesis, it should just be XX. Now that would be an increase in number. Also, Dow syndrome is an example of an increase in number. Have you ever seen anybody raise your hand again about Dow syndrome, you know? Yeah. That's a trisomy 21, the 21st chromosome has 3. So you've got an increase in number. So Dow syndrome and parthenogenesis show this. Now, let's say you have a female, right? A female, and she's got the X chromosome through meiosis in her ovary. Now, if that chromosome changes to a Y, that's going to produce a what?
Male.
A male. So if a female makes a male offspring by parthenogenesis, that chromosome has changed type. So you've got a change in type, and you've got an increase in number, and you have evolution. So that would be an evolutionary birth. Write it down. If a female makes a male by parthenogenesis, that would be an evolutionary birth, because it fits into the definition of change in type and change in number. Now, parthenogenesis is not found anywhere in the Genesis story of creation. It's not mentioned at all. Parthenogenesis is not mentioned anywhere by parthenogenesis. That is evidence of evolution. That is an evolutionary birth. Now, the reason why I'm talking to you about this, once again, it's a theory. Evolution is a theory still. So we're trying to educate you that it is a reliable theory. If it's happening and you deny it, you're kind of denying the truth. It's never good to deny the truth. It's always going to come back and haunt you when you start denying truth. Because science is about truth. The goal of science is to determine what the truth is.